Welcome back, Science 7. Today we are going to continue our chapter 2.2 of Unit E, three classes of rocks: Igneous rock, Sedimentary rocks, and Metamorphic rock. Even though we didn't go through much about these, long story short, we talk about more about sedimentary, which is done by layers of different particles of grains, sand or gravel, silt, whatever you call. There are many different type. We didn't really go through much of a igneous and metamorphic, but some of you guys who play game a lot, anything that ignite, ign is happening, think about that as fiery. So igneous, some sharp people may get it. It's related to temperature. Without further ado, let's get this thing started. All right, let's go through our first type of rock, igneous rock. Igneous rock basically is formed from magma. But there is a key condition. Key condition is, as you may notice, magma is extremely hot and it's not entirely liquid form. It's between liquid and solid. Magma flows inside of the earth layer called mantle, the one that is the thickest layer, right underneath of the earth plates. The thing is, when magma is exposed to the outer environment, can be volcanic activity, or it can be right under the trench deep inside of the sea, between ocean plates and other ocean plates, they get cooled off quite quickly. During that cooling off situation, rocks solidify. So magma is a melted rock, if you guys remember. Like I said, it's located below the earth crust. And for this one, I like to say mantle. And when it flows onto the earth's surface, it is now turning into something I like to call lava. During this stage, basically, we will experience a solidification process like the old GIF picture that I shared in previous lesson. So here's the thing. In igneous rock, we need to think about three different types that you see on the right side. There is one called intrusive. Intrusive rock, which you can see on the picture over here, the cool time takes thousands of years, so it is not a quick situation. And it composes of small to medium grains, so it is relatively heavy, if you will. Medium grains means like, think about like a small gravel, the one that basically break your parents' windshield whenever they drive on the highway. Next type is known as extrusive. Extrusive is one of the quickest one. It takes generally seconds to months. So some people may think, oh, Mr. Kim, several months, it is still far. In our human age, it is far, but when it comes to the earth, rock formation and rock cycle, it is not much. It goes year situation. So extrusive are the one that is basically formed the fastest, and the grain side is mostly invisible because it takes so fast that most of the molten form just turning into a slight solidified form. So we call it the most lightest at one point, least density. And third part is known as plutonic. Plutonic type is basically longest one. It takes millions of years, and it does have large grains, so it can be quite heavy compared to the others. Let's talk about intrusive one. Intrusive ones are basically made by cold and hardened magma, and you guys probably see this type quite a bit. There's some mimicry happen for your kitchen marble floor, not floor, sorry, or sometimes floor, but rarely, marble kitchen table. Think about that situation. They use intrusive quite a bit. So here's the thing. One thing that I will highlight is we're not talking about lava here. We're talking about magma. So this rock is actually formed under the crust. If we talk about extrusive, that's a different story. We are having cooling down situation right under the earth crust, so it is still pretty hot, relatively speaking. However, this is one of the reasons why cooling time takes thousands of years, because it takes that much to cool down fully and solidify. And when it comes to texture, as I mentioned, it is small to medium grains. And some of the example, like the one that you see on the right side, this is called pegmatite. The distinct feature of that is darker dot looking color and white interior design, or color if you will. The other example is known as extrusive. Extrusive example, well, basically these are the rock that forms when lava cools down. So this is outside. This is the one where I like to say directly related to volcanic activity. And one thing that you need to understand is, because it's so suddenly created, most of the color that you see in here is quite dark color. And that makes sense because lava, yes, it have a glowing red color, but when you cool down, it turning into a dark color real soon. Cooling times take really quick, seconds to month. Texture is quite invisible or microscopic size. The grains are really fine, so I like to say fine grain, like a silk situation if you will. Example of that is known as basalt, which is what you see on the right side. These are quite light compared to the others. The other one, the one that you probably see the most, and this is the one that takes the most of the time, crystallized form known as plutonic. Plutonic type, first of all, take the longest time, millions of years. It also happened from magma way below the surface, so this takes the longest time of rising from the deep underground to slightly over. Texture, as you can see, we see quite a lot of large grains, some over here, some over here, quite distinct too. And known example is known as granite. You may see granite time to time. This is a one that used in design quite often because of its beautiful way of irregular pattern, if you will. So I want you to put a little pause button for this video so that you can explain which type of igneous rock would be the lightest, and choose and explain your answer. I'm assuming that now you're done, so let's get through this. My example can be basalt. Oops, totally misspelled it. Basalt. Extrusive and basalt. The reason being is because of one reason. It has the small grain size in its structure, and at the same time it formed really quick. That means time to time, believe it or not, some of you guys don't know, some of those extrusive ones have some holes, and the reason being is air escape. That's why. So this is an example question answer that I can think of. If you want to know more in detail, I'm sharing this summarized table that I created at one point, and each of those property was given. Even though obsidian is not something that we look in grade 7, I want you to look at this quite in detail. You will know then heaviest to lightest situation. The next example that I'm going to focus is sedimentary rock, ladies and gentlemen. This is formed from sediment. Sediment is a fancy way of saying bunch of different layers of rock, minerals, and dead plant and animal matters. They all create layers of distinct, like I said, soil layer, if you will. And then imagine they're making a sandwich, something like that. So when it comes to big components, well, it kind of goes like this. And you have a lot of big grain, then you go to a smaller grain, and then when it comes to a top part, very, very fine grain. Sometimes organic dead matter goes in there too. So generally, the heavy ones, dense one, go at the bottom, and on the top layer, you have least dense. But this is generic pattern. Sometimes density may not play a huge role. Sometimes time plays a huge role. Old layer naturally stack at the bottom, and new layer naturally stack on the top. But like I said, generally, you see most of the big chunk as you travel towards the center of the earth. And when it comes to surface of the earth, you have least amount. Just gonna erase so that I can see this. They are compacted together by the pressure. I want you to really, really emphasize about this pressure. Pressure plays such a huge role. If you think about the layer 1, 2, 3, which one do you think will experience the most pressure? The answer is the bottom part. If we have more layers coming out, the pressure that is happening at the bottom is extremely high compared to the one on the top. You have the least pressure, probably in this case, for the layer number 3. So let's go through sedimentary rock formation a little bit in detail. First of all, small pieces of rocks are carried by water or wind because rock, they cannot move by itself. We need external force. Once you have that movement going, some of them are settle or sink down. Mostly, whatever that is heaviest or highly dense, they are the ones who settle or sink down first. Then, as more and more sediments pile up, the ones on the bottom are squeezed by the weight on the layers above them. So in the end, it will make a sandwich. Enormous pressure causes a sediment into sedimentary rock because as millions of years pass, okay, I exaggerate a little bit, thousands to millions years, the rock sedimentary layers will be solidified and then they become a part of a rock. So the thing is, they have layers. Now I just want to emphasize that. Sedimentary rock always have layers. So let's go through some of those interesting aspects of it. It starts from a very top. If you think about the grain size, it has a lot of air. If you think about, for example, all the way empty space over here, those are the air because they have much of a room between. It's kind of hard to see using our eyes, so it's a microscopic. As you go, everything starts compact. So sediments get compact, and then at the same time, they become so compact that we have a process called cementation. You may know what cement is. Cement, if you think about it, as soon as you apply cement, if it's exposed to outside, it becomes solidified real quick. And as time goes more and more, obviously pressure increases like crazy as time goes because new layer will have a next layer, something like that. And we will eventually create something I like to call sedimentary rock. So sedimentary rocks if you think about it, they have some salt. This is one of the reasons why some of those bad land, like in Drumheller, there's quite a lot of evidence that some of the rock is a bit salty. They have some salt in it because they used to be part of the ocean too. Plus, another reason, as water flow over, here you go. As water flows and carry the particles, they carry dissolved salt too. So water can dissolve salts and other chemical compounds, and those chemical compounds dry up, mix together, and form the thick bed. It dries things up. What about the dead plants and organic matter? That's what Alberta's known for. They become petroleum, petroleum source. Coal for the dead plant, dead animal. They generally turn into our good old fossil fuel oil, if you will. The oil sand, you can think of that one. Organic and living materials sometimes get involved with sedimentary rock formation. Like I said, coal, they're the product from the decay reaction of dead plant matter. And when it comes to those formation, everything starts from our good old stage of pit begins to form, and as you can see, it's more fern that is available on the top. Think about dinosaur situation. As time goes, some of those dead matter will create a layer called lignite. Those are the ones that eventually turning into brown coal, that turning into bituminous coal, and eventually the hardest coal that it will make as time goes will be anthracite. Just know the fact that you don't have to memorize all the coal. Just know the fact that it is continuous process, and the main source of coal is plants, dead plants to be specific. Now we're at the last part. What is metamorphic rock? Long story short, it's involving with our sedimentary rock plus igneous rock. Both of them are combined together, and once that happens, we create something metamorphic rock. So this type of rock has changed its form from what it was originally. Let's see. Even though it has multiple steps, let's think about below the Earth's surface where you're having extreme heat and pressure, so magma. So we're starting with igneous rock situation. Metamorphic rock always have its original form. We call that form parent rock. So original form is known as the parent rock. From the original form, in this case, let's say igneous rock, what happened is there will be volcanic activity. So let's say it come out. Or it takes thousands of years to become intrusive igneous rock. It doesn't really matter, but if it's extrusive, it's going to be quite quick, like basalt. But at the same time, if intrusive, it just takes a long time. But in any case, these guys are somehow exposed to the outside. Then what happens is, because of gravitational force, it's going to roll down and then all the way mix it up with the sediment. And then we have two factors, wind and rain, so water. Those guys carry all of those igneous rock and mix it up with sedimentary layer. So the funny thing is, heat produce igneous rock, but instead of remain as igneous rock, they now go down and become a part of a layer and become a sedimentary rock in addition to being our igneous rock. So now things are combined together. Sometimes sedimentary turning into metamorphic if it undergo extreme heat too. So long story short, you have original form, whether it's a sedimentary or igneous, but depends on the location or flow of this rock cycle. If it undergo high pressure and high heat, then combine them together, we have something called metamorphic rock. Example is shale turning into slate, turning into schists. And that's a quick example that I can give you. As you can see, it looks similar, but it undergoes quite a lot of changes, especially when it comes to slate to a schist. So now, before I give you the homework question, one of the homework question is, I want you to do science log activity. You need to explain why, about metamorphic rocks, why it take the longest time to form compared to the other types, sedimentary or igneous. Today we don't have any other homework other than that, except we do have a Google class assignment. They use Google Forms, so please do the the science log activity first and then Google Form.